Marsh Mill in Wyre is about 200 years old. By November 1988, despite several attempts to get it working and lots of loving care, it was in danger of becoming derelict. Surprisingly, and perhaps uniquely, the mill was almost complete. At first glance, it looked as if it would work, yet something was sadly amiss with Marsh Mill. These cogs, which transfer power from the wind shaft to the wallower, should mesh. Over the years, the entire top of the mill, a structure weighing almost 30 tons, had shifted. Clearly, if the mill was to work again, major surgery was required. Most people don't realize how big a windmill is. The wind shaft, which transfers the power from the sails to the mill itself, is 6 meters long and weighs 14 tons. Even today, it's a difficult job getting it down. One can only wonder how they got it up there in 1794 with just block and tackle to work with. Next, the tail and head ring are removed. Again, these are massive pieces of construction, but once they are on the ground, the extent of deterioration becomes apparent. It's clear that at some stage, the mill was severely damaged. Something shattered these cogs. In addition, bearings have almost worn out over the years.
This is a technique that's been used for centuries, quite commonly found in traditional mills of all sorts. And the great advantage is that the bronze can be renewed once it wears out, but it hasn't damaged the expensive fixed casting or the large shaft that runs in it. So it's a fairly straightforward maintenance operation. In fact, this sort of bearing is still used in motor cars today. This is the pattern for the new bronze shell, which will be cast in the sand mould. We've made it slightly too big, so it won't in fact quite go in. We have to leave a small allowance, make it just a little bit too big, so that when the metal contracts after it's been cast, it will just slide in nicely. And there's a small machining allowance as well, so that we can skim the bore, and it will then fit the wind shaft perfectly.
The curb at the top of the mill is rotten, and the brickwork has started to crumble. This must be put right. The top of the mill rotates so that the sails always face into the wind. If the walls and these timbers aren't sound, the top of the mill may move and wreck the newly repaired mechanism.
We've cut a piece of the oak curb for you to have a look at. And you can see the undersurface is curved. It's probably just a piece of tree that you can see the curved section where the bark has been cleaned off. It's been dressed on its top face, inside radius and outside radius, and simply put down on these blocks to take the load of the cap. You'll notice the beetle attack here, the woodworm. That's particularly bad just here on the underneath, partly because of the damp rising from the wall, and partly because this will be just underneath the bark of the tree. It'll be sapwood that's just a little bit softer than the heartwood, and the beetle can get into that in the presence of dampness, whereas they can't in the heartwood. So that sits on the top of this and is dowelled to it, so that when the cap tries to turn, the fan is turning against the curb. It doesn't push the curb in the opposite direction. These are anchored into the wall, and you can see that one's suffered from the damp a little, come to the end of its life. We shall have to renew those all the way round.
Some of the carpentry is quite intricate. These bird's mouth joints fit snugly together and are dowelled for rigidity. Interestingly, just one bolt is used to lock it together. The reason for this is that in 1794, woodworking was cheap. Handmade bolts cost a fortune. It's worth remembering that the people who built the mill only had hand tools. These beams are perfectly square and were shaped with an adze, a skill long lost to us today. The renovation will take many months, and for those who just about managed to build the obligatory teapot stand at school, it's carpentry on a mammoth scale, and each joint must fit perfectly. Eventually, all is ready. Walls have been rebuilt, and these cast iron slipper blocks on which the mill turns are aligned to an accuracy of 2 millimeters.
The whole of the cap frame has been made new. Most of the timbers were beyond reuse, with the exception of the tail beam that I've mentioned. The two largest timbers are these pieces of softwood here. They're about 26 feet long and 15 inches square. For those who've got metricated, that's just over 8 meters long and 400 millimeters square. They've been planed to a true face and square, and the other timbers that run across are all oak. They're all new, English oak. The joints that we've prepared here are all the traditional proportions. They're double tenoned so that they lodge nicely in the main timber, take a good load, but the tenons are not too long. That means that the housings, the slots in the main shears, as they're called, are not too deep, so it doesn't weaken them too much.
On the main framework, fungicide is applied to protect the vulnerable ends of the timber. The joints are then pulled together. For a perfect fit, the frame must be absolutely square. A few last-minute adjustments and the dowels can be driven home.
Now we've jacked up the upright shaft here and taken out the foot bearing which supports its total weight. This is it. It's a lump of cast bronze, and we can see where the weight has been taken in the centre here. It is slightly worn on its circumference, but that will serve all right, I think, for the future. We've really taken it out to check the thickness that's left below the shaft, the bearing surface, and it seems to be quite adequate. It's about 3/4 of an inch, about 20 millimetres. That should go on for another 100 or 2 years, hopefully. There are a few interesting features about it. You can see that there's what appears to be a crack down here. In fact, it's a chiselled slot which runs right to the centre, and there's a chase up the side here, so that when the upright shaft is sitting in here, one can put oil into this recess here and it will run down into the bottom and lubricate the bearing underneath. The other interesting feature on the underneath is you'll notice that it's had lead dressed into it. That's possibly because it would have been cast that way up in a sand mould and might well have shrunk. In fact, you can see just here where the mould edge was. And when it shrank, of course, it would have had a depression in the middle, but this surface is supposed to be carrying the weight of the shaft. So they would simply have dressed in some lead to strengthen it all up and give it a decent bearing surface. I don't know how long this has been in the mill. I should think 100 years at least, and it may even be the original. So it seems to be perfectly serviceable, so we'll put it back for another couple of 100 years.
Now it's time to refit the wind shaft. Everything must fit together, and with a few minor alterations, it does. For the first time in many years, the cogs on the wind shaft mesh with the wallower. Modern safety touches, such as lightning conductors, are added, but the mill is put back as nearly as possible in its original condition. Millers were obsessed by the fear of the mill getting out of control. This very large piece of wood is, in fact, a very inefficient brake, a brake which only works at all in one direction, and which could easily set on fire if the friction was too great. At last, everything is ready for refitting the sails. Sails that weigh over a ton each and are 6 meters long. The mill was originally fitted with common sails, but photographs show that the ones in use in Victorian times were Cubit's patent sails, and these are faithfully copied. Shutters in the sails open and close automatically as the wind speed varies. Otherwise, the mill would constantly speed up and down, and in a high wind could run away. The shutters are linked to the striking plate, which turns the drive through 90 degrees and controls the shutters via an iron bar, which passes down the hollow centre of the wind shaft to a governor. The striking gear has been completely rebuilt and dated so as not to confuse future historians. The discovery of stainless steel in a piece of equipment dating from 1794 could rewrite the Industrial Revolution at a stroke. Replacing the sails is not the easiest of tasks. Again, we're reminded of the fact that 200 years ago, someone accomplished this without a crane or a hydraulic platform. One by one, the sails are brought into position. It's a long and delicate operation. Until all four are fitted, the whole structure is out of balance. And although of massive construction, they are quite fragile considering the loads they will have to bear. When they are all linked together, they will form a unit which is stronger than the individual pieces. Until then, extreme care is necessary to avoid damaging them. Today, the renovation is complete. The work is done. And Marsh Mill in Wyre stands as a living monument to the men who brought our ancestors their daily bread. A proud day indeed for Wyre Borough Council, who in 1988 took the bold step of restoring the mill.